Assalamualaikum warahmatullahi wabarakatuh to Sir Nazri and to everyone's watching this. First and foremost, let me introduce my fellow teammates, which are FARAH SHAKIRAH, Nur SYAMIMI, Nurul Izzati, and including myself, Nur ALYSSA. In this video, we will be presenting about our experiment number 1, which is the Coulomb's law.
So, the objectives of this experiment are to satisfy Coulomb's law experimentally, to study the parameters that affect the electric force, lastly, to find experimentally the electric constant K. We move to the procedure pipeline. Firstly, the following was split. The charge Q1 and the distance R were fixed. The values in the table 1 were written. Next, the distance between two charges were changed as shown in table 1. Then, the force value for each distance was recorded. Last but not least, table 1 was filled by finding R the power of 2 and 1 per R the power of 2. So, these are the values we get by measuring each distance. When D is 10 cm, Fe Newton is 3.60, D 9 cm, Fe is 4.44, when D 8 cm, Fe is 5.62, D 7 cm, Fe 7.34, D 6 cm, Fe is 9.99, D 5 cm is 14.40, D 4 cm is 20.50, and when D 3 cm, Fe is 39.94. The next presenter will explain more further about how we obtain this value.
So for table 1, the charge 1 and 2 are constants, which are -2 microcoulomb and 2 microcoulomb. Only the distance r are being manipulated, so it decreases in centimeters from 10, 9, 8, 7, 6, 5, 4, and down to 3. For r squared, all of the written values of r were being changed from cm, which is centimeter, to m, which is meter, by dividing the values with 100. Because 1 centimeters is equals to 0.01 meters, and it will be squared to find r squared in meters squared. So the values from the top to bottom is 0.01, 0.0081, 0.0064, 0.0049, 0.0036, 0.0025, 0.0016, and lastly 0.0009. Next, to find the values of 1 over r squared, we simply divided 1 with r squared, and we obtained the first value to the last value, and those are 100.00, 123.46, 156.25, 204.08, 277.78, 400.00, 625.00, and lastly 1111.11. And for electrical force, it was measured in Newton based on the above formula, which is F is equals to K times with charge 1 times with charge 2 and divided by r squared. F is in Newton, K is a constant with a value of 9 times with 10 to the power of 9, Q1 and Q2 are in coulombs. And the values obtained were 3.60, 4.44, 5.62, 7.34, 9.99, 14.40, 22.50, and last but not least, 39.94.
So, from the data we previously obtained, we plot a graph between electrostatic force and R, which is the separation distance between the charged objects. A curved graph was obtained from it. It shows a decreasing curve line as the square of distance R increasing and electrostatic force decreasing. The graph continues to decrease until the end of R at 0.10 meter, and it is an inversely proportional graph. Next analysis is to plot a graph between the electrostatic force F and 1 over r squared. Okay, we obtained a directly proportional graph from the data we recorded previously. So, how do we find the percentage error in K? First of all, we find the gradient in the formula of m equal to rise over run, and we got 0.0359. Later, the m we obtained, we substitute in the formula of y equal to ms plus c. In this formula, we took y as electrostatic force as it is in y-axis, and since 1 over r squared in the x-axis, we will replace their value in the value of x in the y equal mx plus c. At the end of the calculation, we got our experimental value as negative 8.98 times 10 in the power of 9. So the last step to find our percentage error is the value of the experimental value we subtract by the theoretical value and divide by the theoretical value again. So the theoretical value that was given is 9 times 10 in the power of 9. So the value of our percentage error is 0.22, which can be accepted.
Okay, now I'm going to give a brief explanation on the procedure of experiment 2. Number 1, the following link was clicked. The charge Q1 and the distance R were fixed. Their values in the table 1 were written. Number 2, Q1 was controlled and fixed at 5 microcoulomb, and the distance between the two objects was fixed at 6 centimeter, and the data has been recorded in the table 2. And lastly, the charge of object 2 was changed as shown in the table 2, and for the electric force between the two objects in table 2 for HQ2 was recorded. So these are the first 4 results for electrical force that were obtained with constant Q1 5 microcoulomb and constant distance R, which is 6 centimeter, and the value of Q2 are from the table given in the lab manual. This is the remaining 4 results of the experiment. My teammate, which is Izzati, will be elaborating further about the results obtained.
So this table is for result part 2. Like in procedures part 2, Q1 has fixed at 5 microcoulomb and the distance between two objects R has fixed at 6 cm. Only the Q2 has changed and the electrostatic force was determined from formula F equal to K multiplied with Q1 and Q2 per R squared. So when Q2 is 10 microcoulomb, the Fe is 124.83 Newton. When Q2 is 9 microcoulomb, the R that we'll get is 112.34 Newton. The Fe is 99.86 Newton when the Q2 is 8 microcoulomb. When Q2 is 7 microcoulomb, so the Fe is 87.34 Newton. Q2 equal to 6 microcoulomb, the Fe is 74.89 Newton. 5 microcoulomb and 4 microcoulomb for Q2, so the Fe that will get are 62.41 Newton and 49.93 Newton. Lastly, when Q2 is equal to 3 microcoulomb, so the electrostatic force that will get is 37.49 Newton.
In this analysis, we need to plot a graph between electrostatic force F and particle 2 or Q2. From the data we recorded, linear or straight graph was obtained. It shows an increasing line as charge of Q2 was increasing along with electrostatic force F. It is a directly proportional graph because charge of Q2 was increasing, electrostatic force also increasing. Then we need to find electric constant K, and from the gradient formula we got M as 1.248 times 10 in the power of 7. Then we substitute M in the straight line equation to find K. So from the calculation, we obtain K as 8.99 times 10 in the power of 9. So to find percentage error, we substitute K we got in the percentage error formula, and from the calculation, our error was 0.11%, which is pretty precise to the theoretical value.
Discussion. First, Coulomb's law states that the electric force between two charges is proportional to the product of the charges and inversely proportional to the distance between them. Second, this Coulomb's law experiment was divided into 2 parts, which are part 1 and part 2. Third, the part was using the fixed charges for Q1 and Q2. The value of Q1 is negative 2 microcoulomb and the value of Q2 is 2 microcoulomb. Only the distance between Q1 and Q2 that has been changed. This can be more clearly seen in the table 1. Fourth, the graph that has been obtained from part 1 shows that the Fe is inversely proportional to R. The value of electric constant K that obtained from the graph
through the formula. Fe equal to K multiplied with Q1 and Q2 divided with R squared is 8.98 multiplied with 10 power of 2 nanometer squared. The error percentage is 0.22%. 6. Part 2 was using a fixed charge of Q1, which is 5 microcoulomb, and the fixed distance between two charges, which is 6 cm, but change the charge of Q2 as shown in table 2. 7. The graph Fe versus Q2 shows that the electric force is directly proportional to the value of the Q2. The value of electric constant K obtained from the graph Fe versus Q2 is 8.99 multiplied with 10 power of 9 Newton meter squared. The error percentage for part 2 is 0.11%. 8. For the precautions when conducting the experiment, the eyes should be vertical and perpendicular to the scale to avoid parallax errors.
Last but not least, we can go through the conclusion. Based on the experiment, we can conclude that the objectives of this experiment are all acceptable. We can satisfy Coulomb's law experimentally. We can study the parameters that affect the electric force. We can find the electric constant K experimentally. The hypothesis of this experiment is also acceptable. The electric force is influenced by the distance of the two spheres. Based on Coulomb's law, K bracket Q1 Q2 per R the power of 2, it states that the force between the two charges is proportional to the product and inversely proportional to the square distance. When the charges are the same, they will repel. When the charges are opposite, they will attract each other. The electric force is also influenced by the distance. This law holds the energy and prevents it from disappearing. So that's all from us. Thank you for lending us your ears. Stay safe and thank you.